Hello everyone, welcome. Today we are solving linear equations. Now, a linear equation represents any equation, I like to abbreviate, in one variable, guys, in one variable. Typically, you will see the linear equation in the form of ax plus b is equal to 0. Now, these equations, we refer to them as first degree equations because the power on the x variable, okay, is 1. Here, let me circle this for you. So therefore, when you solve these type of problems, you're looking for exactly one solution, which would make the original problem true. So your goal is to find that one value. Not all equations will have a single value that will make it true. There are exceptions to this case, guys. So the question is, how do we get to that one solution? Here are some steps. Step number 1, you are to go ahead and eliminate or get rid of the grouping symbols. And what are the grouping symbols? These are the parentheses, guys. And to do this, you're going to be using the distributive property. So use the distributive property in order to eliminate the grouping symbols. I'm going to give you a quick example of this because I need you to understand what's going on. So moving on, let's say you are given 3 times 2x minus 5. You've got is equal to 6. I'm just making this up as I go along. So you got an equation that contains parentheses. So you want to eliminate the parentheses. To do so, you would take the 3 in front of the parentheses and distribute it, multiply it by every term inside the parentheses. By doing this, you end up with 6x minus 15 is equal to 6. All right? So that's the distributive property. Now, step number 2, every once in a while, you will encounter some fractions in here. If you should encounter fractions, guys, you need to eliminate the fractions. Eliminate the fractions by multiplying, I'm abbreviating again, each term by the LCD. Now, why do we want to do this? We want to do this, guys, because nobody likes working with fractions, so get rid of them. By the way, LCD stands for the lowest or the least common denominator, okay? So LCD is the least common denominator. Now, here's a quick example of this, guys. Let's say I have 1/2 plus 2/3 A is equal to 1/6. Obviously, there's a whole bunch of fractions in there. I don't want to work with the fractions, so I need to find the LCD between 2, the 3, and the 6. What is the smallest number that 2, 3, and 6 can go into evenly? That would be 6. So now I am going to get rid of the fractions by multiplying every term. This problem has 3 terms. This is 1, 2, 3 terms, okay? So now I'm going to eliminate each fraction by multiplying the terms, each term by 6. Multiply each term by 6. Now, when I'm multiplying by the 6 here, guys, pretend the 6 is over 1. So essentially, I am just going to simplify. So 2 goes into 6 3 times. So 3 times 1 gives me 3. So that's what the first one simplifies to. The other thing you can do is, what's half of 6? That's 3. Or you could do 6 times 1 is 6. 1 times 2 is 2. What's 6 divided by 2? Same thing. Now we're going to go to the second fraction. 3 goes into 6. How many times? 2 times. So you're going to take the 2 multiplied by the 2 over here. So that's going to give you 4a. Remember, the goal here is to eliminate the fractions, guys. And then 6 goes into 6 once, so they cancel each other out. So what are you left with? Just 1. So guys, our goal was eliminate fractions. We've accomplished that, so we are good, okay? So next step is to go ahead and combine like terms. Now be careful when you're combining like terms. When you are combining like terms, if the terms are on opposite sides, one on the left, one on the right, you may have to use inverse operations. And what I mean by that is if a term is adding, then you might want to go ahead and subtract to go ahead and work it out or combine those terms, okay? So be careful with this. So what in the world am I talking about? Here's a quick example. Okay, so on this example right here, I have 3x minus 2 plus 5x is equal to 2x minus 8. Now I want to combine like terms. So I'm going to take the 3x and the 5x because they're on the same side. I'm just going to combine them together. So I get 8x, bring down the minus 2, bring down the 2x, and then minus 8. Next, the 2x and the 8x need to be combined together. Notice I'm doing the x's first, guys, not the numbers. There's a reason why we work on the x's first. We try to combine the x's first. And once in a while, the variables cancel out. If the variables cancel out, there's no point in continuing with the problem. So it's best to go ahead and combine the x's first. Then you want to go ahead and work on the numbers. Now, notice, guys, I am subtracting 2x on both sides. Why? Because, number one, the 2x needs to be combined with the 8x. Number two, the 2x is positive, so I want to do its inverse to bring it over to the left side. It's on the right side, it's positive, okay? It's adding. So if I want to bring it over to the left side, I'm going to have to subtract both sides by the 2x. So basically, 2x takes away x right here. And on the left side, 8x take away 2x leaves me with 6x. Now bring down the minus 2. Bring down the negative 8. Next, we want to combine the negative 2 with the negative 8. The negative 2 is on the left side. The negative 8 is on the right side. So in order to combine them together, we're going to have to move the 2 over to the 8. Since it is subtracting, we're going to do the inverse of subtraction and add the 2 to both sides. So thereby, this cancels out, leaving you with the 6x on the left side, and a negative 8 plus 2 leaves you with negative 6, okay? So now, guys, once you have all your terms combined, the like terms combined, what you're left with is a very simple equation. And it is simply asking 6 times what gives you negative 6, and everybody should know that is a negative 1, but I didn't quite finish it, okay? So let me go to the last step, guys, on finishing up with solving a linear equation. Now, the last step, step number 4, is to isolate the variable. Isolate the variable. Now, when you're isolating the variable to get it by itself, that's what that means, get it by itself, guys. Typically, you have to either divide, let me go ahead and abbreviate here, divide or multiply. In other words, do the inverse operation. So you're going, the last step is typically to divide or multiply to isolate the variable. And I'm going to put step 5 over here, which is to check the solution. It doesn't hurt to take some time to check your solution. There's nothing wrong with checking your solution, guys. It actually helps, especially on a test. Remember, there's a quiz coming up soon. Okay, so on that last problem, we got to this step right here, negative 6x. Actually, it was a positive 6x equals to a negative 6. So here we want to isolate x. Since the 6 is multiplying x, we're going to do the inverse of multiplication. Remember, the inverse of multiplication is division. Likewise, the inverse of division is multiplication. So we're going to divide both sides by the 6. So then the 6's cancel out, leaving you with x. And if you take negative 6, you divide it by positive 6, that leaves you with a negative 1. So guys, this completes the problem. So the solution is a negative 1. And that's it, guys. That's how you solve these linear equations. Now, I'm going to finish out some of the other problems which I started working with you, like the one with the fraction. When we simplified it out, it simplified to 3 plus 4a is equal to 1. Now, on this one right here, to simplify it, what happened to my problem? Shazam. My problem just disappeared, guys, okay? So 3, oh, there it is. Whoa, okay. Something's going on. All right, there we go. So guys, to finish this one out, I want to combine the 3 with the 1. Leave the a, the 4a on the left side. So I'm going to subtract the 3 from both sides. I'm going to subtract the 3 from both sides. So here, the 3's cancel out, bring down the 4a. 1 take away 3 leaves me with a negative 2. The last step, since 4 is multiplying a, I'm going to divide both sides by 4. So this cancels out. Now guys, remember in Math Excel, you must reduce your fractions. You don't have to be told to. You should automatically reduce them. So this reduces to negative 1/2. Don't put the 0.5. The computer will mark it wrong. So make sure you're including the fractions, okay? So now let me do some of the additional examples for you guys. Here's an easy one, guys, very easy. It is example number 1. I've got 3 times x minus 6 is equal to 5x. So we're going to distribute, get rid of the parentheses. So we distribute to get rid of the parentheses. So this is what we end up with. Next, we want to combine the variables together. So I'm subtracting 3x from both sides. So this cancels out. Bring down negative 18. 5x take away 3x leaves you with 2x. And so the last step for this problem, since the 2 is multiplying x, is to divide both sides by 2. So this cancels out, leaving you with x is equal to a negative 9. Now, if this is moving a little too fast for you, remember guys, this is a video. You can always slow it down, go back and go over it again. All right. So here comes example number 2, guys, and then we'll get into some fractions. Negative 2 times the quantity 5y minus 1 minus y is equal to negative 4 times the quantity y minus 3. So now, guys, I am going to simplify this, okay? I'm going to solve this equation by first simplifying out the parentheses. Get rid of the parentheses. Distribute the negative 2. Distribute the negative 4 right here. Okay, when we distribute, we end up with a negative 10y plus 2 minus y equals to negative 4y plus 12. Next, we're going to combine like terms. On the left side, be careful. We have a negative 10y minus y. So when we combine them together, guys, you might want to remember that there's a negative 1 here. So this is going to become a negative 11y. Bring down the positive 2. And on the right side, you still have the negative 4y plus 12. Now, from this point on, guys, listen, it's up to you what you choose to do. It doesn't matter which side the variable ends up on. As long as you have the variable isolated, you have the variable by itself on one side, it doesn't matter which side it's on. So it's up to you. Personally, I like to move the smaller variable over to the larger variable. In this case, negative 11y is smaller than negative 4y. So I'm going to take that negative 11y and add it to both sides. Add it to both sides. So guys, this cancels out. I bring down my 2. Negative 4y plus 11y leaves me with 7y plus 12. Now, when I get here, I'm going to have to combine the 12 with the 2. So in order to do so, I'm going to subtract 12 from both sides. So this cancels out. 2 take away 12 leaves me with a negative 10 equals to 7y. Now, guys, listen, there's nothing wrong with fractions. It's okay if you get a fraction. It's okay, guys, okay? So on this particular problem right here, I'm just going to go to the side and kind of like finish out this problem. So I'm at negative 10 is equal to 7y. So to finalize this, I'm going to divide everything with sides by 7. So y is equal to negative 10 over 7. And there you are. And that's it, guys. That's it for example number 2. Now I'm going to get into the fractions, which is everybody's albatross. Everybody has an issue with fractions. So guys, I'm going to do 3 of them. And as I do these questions, okay, pay careful attention, guys. So many of you don't like working with fractions. So ideally, you want to go ahead and get rid of the fraction. So example number 3, I've got x over 2 plus x over 3 is equal to 3/4. The denominators are 2, 3, and 4. So you want to find the LCD between 2, 3, and 4. To find the LCD between 2, 3, and 4, guys, remember you're looking for that smallest number that 2, 3, and 4 can go into evenly. Okay, some of you might say 6. Can 4 go into 6? No. Some of you might say 8. Can 3 go into 8? No. So the smallest number that all 3 of these can go into would actually be 12. So now, guys, I am going to proceed to multiplying every single term by the LCD of 12. So I can go ahead and eliminate out the fractions. And guys, it is as simple as this, okay? 2 goes into 12 6 times. 6 times x, 6 times the numerator gives me 6x. 3 goes into 12 4 times. 4 times x is 4x, okay? So there we go. That's a 4 right there. Now, next, 4 goes into 12 3 times. 3 times 3 gives you 9. Guys, look at that. Amazing. Once the fractions have been eliminated, look at how easy the problem is. So now all you need to do is combine 6x and 4x and get 10x equals to 9. And then divide both sides by 10. So guys, your answer is 9 over 10. And that's it. I know, very simple. Okay, but let's go ahead and take another one, guys. Number 4. Now for number 4, it's 9t over 14 minus t over 2 is equal to 1. Now, for this one, very similar to the previous problem, again, the denominators are 14 and 2. You got to find the LCD between 14 and 2. What is the smallest number that both 2 can go into and 14 can go into? And no, it is not 7, guys. 14 does not go into 7, but it is going to be 14 because 2 can go into 14 and 14 can go into 14 evenly. So the LCD for this one is going to be 14. Now, here's another way you can approach the problem, guys. Put a big bracket around the entire problem and multiply by the 14. This is the same thing as multiplying each term by the 14. So when you multiply this first term right here by 14, the 14s will cancel out. They will cancel each other out. So what are you left with? Just the numerator. So 9t. For the second fraction, you could even ask yourself, 2 times what? 2 times what gives me 14? What do I multiply 2 by to get to 14? I would multiply it by 7. So whatever you do to the denominator, you must do it to the numerator. So the numerator just simplifies to 17. And last but not least, that 1 is a term, okay? So you want to multiply it by the 14 so you get 14. Now, guys, look at how easy the problem is. We've eliminated the fractions. So now you can go about finishing the problem. So 9t, take away 7t, leaves you with 2t equals to 14. And then you want to divide both sides by 2. So t is equal to 7. And there you are. All right, guys. Now, I know this one seemed difficult, but that wasn't really challenging. So here's the one that's super challenging, guys. Hopefully you do well with it. And of course, as always, I will go over some examples in class with you. N minus 3 over 4 plus n plus 5 over 7 is equal to 5 over 14. Ooh, this looks menacing. Okay, guys, so the denominators are 4, 7, and 14. Now this time, I'm actually gonna go to the side, guys, and show you step by step how you come up with the LCD. Now what I'm gonna do, guys, I'm just gonna go over here. I'm going to factor 14 into its prime factors, 2 times 7. 4 is 2 times 2. And then, let me go ahead and erase some of this. All right, so let me go ahead and put the 4 up here. 4 is 2 times 2. And then you've got 7, which is just 7, okay? Circle the like factors. Circle like factors, and there we go. The LCD is a product of all the like factors, 2 times 7, the ones that we circled, and any remaining factor, the one that we did not circle, becomes part of the LCD. So when you multiply all of this together, by the way, product means multiplication. So when you multiply all of this together, what do you get? 28, guys. That's the LCD. Now, guys, here comes the next part. So the next part is to multiply every term by the LCD of 28. Every term gets multiplied by 28. So now we're going to go ahead and simplify this out. So 4 goes into 28. How many times? 7 times. Guys, notice what's in the numerator, n minus 3. So you're multiplying the entire numerator by by 7. Same thing with the second fraction. 7 goes into 28 4 times. So now you're going to have to multiply the entire numerator by 4. I forgot to write the 4 there. Actually, I was trying to write it. It got cut off. Okay? I'm still trying to write it, guys. So next, 14 goes into 28 for the third fraction 2 times. So you're going to multiply here the numerator by 2. So 2 times 5, guys. I'm writing it out for you so you can actually see where these numbers are coming from. So 5 times 2. And guys, just like that, the fractions have been eliminated. So now all you have to do is distribute the 7, distribute the 4, distribute the 5. So guys, let's distribute the 7. We get 7n minus 21. Distribute the 4. We get 4n plus 20 equals to 10. And then we're going to combine like terms. 7n plus 4n is going to give us 11n. And of course, the negative 21 plus 20 is going to give us a negative 1. And all of this will equal to negative 10. Now add 1 to both sides. So you get 11n is equal to 11. 11 times what gives you 11? Oh, it has to be 1, guys. And guys, that's it for solving the linear equations. Now, one more thing I do need to say about solving the linear equation, and then I will be done with this, okay? And that is the other types of solutions. So all these problems we just did, like this last one, guys, we got n is equal to 1. All these type of problems where we're getting one exact solution, we refer to them as a conditional equation. That is the majority of equations you solve. When you solve them, you get an exact solution, one solution. So what's a conditional equation? Basically, it's this, guys. The equation is true, as in the left side is equal to the right side, on the condition that, in this case with the previous problem, n is equal to 1. Some of the other questions we did, like the one where we got n is equal to, what was one of the solutions? I can't remember, 1/2, okay, negative 1/2. The equation is true on the condition that the variable is equal to negative 1/2. The equation is true if the left side is equal to the right side, so they balance each other out. Okay, guys, so besides these conditional equations, there are 2 more types of equations. There are equations such as this one right here, guys. 2 times 3x plus 1 is equal to 6x plus 3. If you try to solve a problem like this, guys, by distributing the 2, this is what happens. You get 6x plus 2 is equal to 6x plus 3. Now, remember I said earlier, it's always a good idea to eliminate the variables first. Look at what happens if you subtract 6x on both sides. Notice this, guys. The variable cancels out here, leaving you with just a statement. So you need to pause and ask the question, guys. Is 2 equal to 3? Is the left side equal to the right side? Is this statement true or is it false? This statement is false. And no, the left side is not equal to the right side. No, 2 is not equal to 3. One of the things I like to tell students is this, just write solution after it. Once you answer it and you say no, just write solution after it. So there you go, no solution. When you have an equation where the left side doesn't equal to the right side, we say that the equation contradicts itself. We call it a contradiction. And the name we really use when it comes to the no solution equations is inconsistent. And then the symbol we use for this is a 0 with a slash through it, guys. That means no solution. So this is the second type of equations you could encounter when solving an equation. All right. Now, here's the third type, guys. Now, for this third type, let me go ahead and give you this problem right here. It is 2 times 3x plus 2 is equal to 6x plus 4. Now, for this type of equation, just like with the previous one, if we attempt to solve it by distributing the 2, we get 6x plus 4 is equal to 6x plus 4. I'm pausing here. I want you guys to notice, look at the left side. Look at the right side. What do you guys notice? You should notice that they are exactly the same. They look the same. They have the same terms. When two things are exactly the same, guys, we call them identical. They are identical to each other, okay? And I'm going to come back to that in a minute. But let's say you can't notice this and you continue subtracting the 6x from both sides. I want you to notice what happens once again. You end up with a statement. Now, this particular statement is actually true. Is 4 equals to 4? Yes, 4 is equal to 4. So you have a true statement. Did I put true on the previous one or did I put false, guys? I just realized something. I probably put true on there. It's supposed to be false, okay? I'm not quite sure. I might have to go back and check that on the video. Okay, guys, so because it's a true statement, this means whatever x value plug in, you're going to plug in the same x value on the right side. So the problem will always be true regardless of what value you plug in. So these type of equations, we say they have many solutions, or we could say all real solutions, and sometimes we'll hear it referred to as all reals. The symbol we use for this is a big capital R like this, guys, meaning all real solutions. Sometimes it's referred to as infinitely many solutions. Infinitely many solutions. Shazam, okay? So guys, it doesn't matter how you say it. The point is every single real number will make the problem true. So what kind of name do we give an equation like this? We don't call it identical. We actually call it something very close to identical. We call it an identity. Identity. Because the left side is exactly what you see on the right side. And just like that, guys, we are done with solving linear equations. I will answer additional questions in class. So until next time, bye, everybody.